Hi, I am Varun Joshi and welcome to day 56 of our Certified Kubernetes Administrator 2025 course. In today's lecture, we are focusing on observability in Kubernetes, what it is, why it matters, and how to get practical signals fast. We will cover three pillars of observability, and these pillars are metrics, logs, and traces from both infrastructure and application perspective, because you as DevOps engineers would be handling both infrastructure and applications operations. We will walk through metrics server architecture and explain how it scrapes kubelets and serves the metrics API. Then we will map Kubernetes monitoring, covering what you get out of the box and where resource signals come from. We will also cover Kubernetes logging, showing where pod and node logs live and how to read them with kubectl logs and journalctl. And while going through the entire lecture, we'll be discussing best practices. For example, where you should store your logs, how should the monitoring posture look like, and how should the applications be configured so that you can use tooling that is natively available for you. With that said, let's get started. Observability. Firstly, what is observability? Observability is the ability to understand the internal state of a system from signals it produces. And now these signals are metrics, logs, and traces. For example, if I have a Kubernetes cluster and I want to know what is happening inside my cluster, then I should receive certain things which will let me decide that my cluster is working properly. And when I talk about observability in general, then these things are metrics, logs, and traces. These three things will tell me whether everything inside my cluster is working properly or not. And I want to give you an analogy here. When you go to a doctor will diagnose the problem based on certain external signals. For example, what is your temperature, what is your blood pressure, how is your heartbeat like, and based on that, doctor will choose the line of treatment. Similarly, in Kubernetes, there are external signals, and based on those external signals, you decide whether the cluster is functioning properly or not. If it is not functioning properly, then you decide the line of treatment for your cluster. And if something is not right, then doctor will cut you open. Similarly, if something is not right with your cluster, then you as a DevOps engineer will log in into your cluster and then fix the problem. For example, if a node is continuously rebooting, then you will log in into that node and troubleshoot that problem further. So you will have to cut open the server. And I want you to know that when you are working in a Kubernetes cluster, your nodes and pods, all of them will be coming and going. So you will not be essentially SSHing into your nodes. You will be watching your observability structure and then deciding what to do. And most of the troubleshooting is there when you read the logs. Hence, having a good observability structure is of utmost importance, especially for enterprise grade environments. Now, I want you to understand that we are DevOps engineers, and for us, there are two perspectives when it comes to observability. There is an infrastructure perspective, and then there is the application perspective, because we must ensure that the infrastructure on which our cluster is running is working smoothly, And then we also must ensure the operations of the application are running smoothly. And if need be, if based on further diagnosis, we decide that this is a problem that is relevant to application teams, then we open appropriate tickets so that application teams can take the job of troubleshooting that problem. But the initial troubleshooting for application perspective as well lies with us DevOps and SRE folks. So we must understand observability from both of these perspectives, application perspective, and then there is infrastructure perspective. Now infrastructure will carry your virtual machines, your networking, your storage, how is everything working, and application will take into account whether the application running onto the hardware, onto the infrastructure is working appropriately or not. So if I talk about infrastructure, your focus will be on the overall cluster health, the nodes, the pods, the networking, the storage. And the questions that you will be asked often are, is the cluster healthy? Are the nodes overloaded? Are the pods crashing? Are there enough resources? Have you as DevOps engineer ensured that you are configuring requests and limits so that your pods are not being overutilized? Have you configured pod disruption budgets to ensure that during planned activities my critical applications still work smoothly? Have you configured pod priority so that my pods which are critical can be deployed when there is contention? So have you configured these things to ensure that the infrastructure is behaving as expected? This comes under the infrastructure perspective. Now let's contrast this with application perspective, and after that we will discuss what tools are available at your disposal to troubleshoot these problems. Then application perspective, the focus will be on the application behavior, the latency error, the user experience, and the questions that will be asked here are, is my app responding fast? Are requests failing? Whether I am achieving my rate limits, do I have to increase my rate limits? Where is the bottleneck across services? If I have 10, 15, 20 microservices serving an application, and if that application is behaving smoothly, then where exactly is the bottleneck? You as DevOps engineers will be receiving all these logs, and you can use any distributed tracing software to understand where the lag is and then pinpoint it to your application teams that on the basis of my initial troubleshooting, I feel this microservice is not behaving as it should, which is why the requests are taking long and the user experience is deteriorated. It is your job to ensure these things. Now that we have an understanding of both these perspectives, let's talk about different tools that are available for you. Now, I want you to know there are 3 pillars of observability like we discussed before, and each perspective will also have their respective pillars. So for example, here I have metrics, logs, and traces. These will be for your infrastructure layer. For example, your EC2 instances on which your cluster is running, or your control plane node statistics. And this is applicable for both self-managed clusters and your cloud provider managed clusters. So here you see, when I talk about tools, the tools are metrics server. So if you want to, let's say, monitor your cluster, you want to see what is the utilization of your pods, your nodes, then you can use metrics server, which collects data from the kubelet, and kubelet has a cAdvisor component, and we'll see the architecture of metrics server in a little while. And then there is Prometheus, there is node exporter, there is CloudWatch. If I talk about native cloud tools, you have CloudWatch, you have Azure Monitor, and then FluentD, Loki, EFK. All these tools are available for you to use to achieve all of these 3 things. And similarly, If I talk about application perspective, then you have open telemetry, Jaeger, and Jaeger is something that you can use when you want to perform distributed tracing. Then you have Tempo, Datadog, APM, New Relic, Dynatrace, and I mentioned a word APM here. APM is application performance monitoring. Now, I want you to contrast APM with something you already know. So just like DevOps, what is DevOps? DevOps is a culture. It is not a single tool. You cannot touch DevOps. DevOps is a culture. You cannot buy a license for DevOps. You buy a license for a tool, but DevOps is something that is logical, that is an abstraction. So it is a collection of tools. This is DevOps. Similarly, APM is application performance monitoring. So APM is a practice of applying all these three pillars. So when I talk about application perspective, we can also write APM in parentheses because APM covers all of these three things. The goal with APM is understanding performance, dependencies, and user experience, and all of this can only be understood when you have these three things with you: the metrics for the application, the logs, and the traces. Now that we have this high level understanding of how the observability structure might look like, let's discuss what are the key things that we monitor for these specific pillars. So if I talk about infrastructure, what are the metrics that you typically monitor? You monitor the CPU, the memory, pod restarts, disk utilization, network bandwidth, IOPS, and so on. If I talk about logs, we want to ensure that the pod logs, the node logs, and even if something is deployed as a service, all those logs are available with you, including the control plane logs. Then finally are traces. Now when I talk about traces, these are not much used when I talk about infrastructure layer, but you would see when you have a big environments, enterprise grade environments, you would see DNS resolution requests are also traced. An important point to mention here is if you are working in a highly security governed environment, then you will also have something like VPC flow logs configured. If I talk about AWS, VPC flow logs will help you collect all the logs for your VPC and your subnet, and also your ENIs optionally, so that you can see if the request is getting delayed or how the request is flowing in an end-to-end way. So for that you can include traces, but when I talk about smaller production grade environments, then traces at infrastructure level are not used that much. Now let's understand these three from application perspective. Now metrics, logs, and traces. Metrics: what is the latency in your application, throughput, error rate, database query time, cache hit ratio. All of these are examples of metrics that you will be receiving or you would be configuring, and these are just examples. You could have many more metrics configured based on the needs of your application. And what are the logs? Logs are access logs, or your application error logs, or your application login logs, and so on. Anything logs will be catered with the logging pillar. Then there are traces. Now you want full traces of your application. What is happening, where the request is taking long time. So if you have 10 microservices, like I told before, you want to know which service is misbehaving, which is causing bad user experience. I also want you to know that there are multiple tools that are available at your disposal, but when you are dealing with an enterprise grade environment, you would typically see that there is a single tool that is used for observability of both infrastructure and application. For example, you could be using Datadog, and Datadog will be doing your end-to-end monitoring, logging, and tracing. So an enterprise environment will be using an enterprise grade tool which will be doing the entire observability for them, be it infrastructure or be it application. And with this understanding, I want to take you to my GitHub notes where I will show you how native AWS services can help you achieve observability for your application deployed onto AWS. And Azure and Google will have tools which can help you achieve the same. So let's go to my browser, and from here I will click on observability in AWS with native services. Now here you see when it comes to infrastructure, and here is the application perspective. So from infrastructure perspective, metrics, you can use CloudWatch metrics, container insights, AMP is AWS managed Prometheus that can also be leveraged. Then for logging, you can use CloudWatch logs insight, container insights, AWS CloudTrail. This can help you with audit and security events. Then when it comes to traces, you can use VPC flow logs, network level telemetry, AWS distro for open telemetry. Then if we talk about application observability, then for metrics you have CloudWatch metrics, application signals. This is still in preview stage. Application signals will help you track your SLOs, and this falls under the CloudWatch suite. You see it here as well, CloudWatch application signals. Then you have logs, CloudWatch logs. CloudWatch logs can be used to collect logs from multiple AWS services. Then finally you have traces. This is essentially your AWS X-Ray, which is a distributed tracing service. There is CloudWatch RUM, real user monitoring, via which you can track when a user has logged in, how the request is flowing. Then there is CloudWatch synthetics, which can help you simulate a user request for your application. Then CloudWatch application signals, like I told you, this can be used to achieve application SLOs. Then ADOT is AWS distro for open telemetry. So together these services give you the ability to collect metrics, logs and traces across both infrastructure and applications. Now see, I have added all these things so that you can understand how observability is implemented in a production grade environment. I believe that a high level understanding of how things work help. So with that understanding, let's scroll down and see what the next topic is. Now I want to discuss Kubernetes monitoring. In the parenthesis you see native, because the CKA exam is concerned about how the native monitoring and logging functions in your Kubernetes cluster. So first point is no built-in full-fledged monitoring solution. But Varun, I have been using metrics server, which is a add-on, and I can see what is the utilization of my nodes and pods just fine. Then how come it is not a monitoring solution? So understand that monitoring solution should be able to give you utilization statistics. For example, if I know the CPU right now, I want to know the trend for the last 7 days or last 1 month, so that I can take decisions based on the average utilization. So a full-fledged monitoring tool will be storing my metrics, and then I can run analysis on top of those metrics. So metrics server is not a full-fledged monitoring solution. Second is metric server needed for kubectl top, HPA and VPA, and we have seen this in our past lectures, especially in auto scaling and requests and limits, that when you want to use HPA or VPA, then you would definitely be configuring metric server. And if you want to see the utilization of your pods and nodes, then also metric server is a must. Collects CPU and memory usage, and we have seen that. I want to show you one thing. So if I go to my GitHub notes, and then here I'll click on top, and then from here I want to show you this metric server. So I already have metric server installed in my Kubernetes cluster. You can install the same. The steps are here. Additionally, If you have configured the Kubernetes cluster using the day 54's video where we configured a multi-node cluster using kubeadm and Calico as our CNI, then I would suggest you also run this command for metrics server to work properly. Here what we are doing is we are changing the mode from VXLAN cross subnet to just VXLAN. So just read about it. You do not have to understand it that deeply at this stage, but just apply these commands and metrics server will work perfectly. So if I go to my terminal, here is my cluster kubectl get nodes. I only have a 2-node cluster right now because I have not configured the second worker node. So you see I have a cluster with only 1 worker node. If I run kubectl top pods, then I will see the utilization of my pods. And if I run kubectl top nodes, and then I can see the utilization of my nodes as well. And before I move ahead to the next point, I want to tell you the architecture of metrics server. So what you see here is, here are your nodes and here are your pods, and we understand that all our nodes run kubelet. I have shown it separately to make the understanding simple for you. Now kubelet has a component called cAdvisor. Now cAdvisor is part of the kubelet binary. You do not have to install it separately. What this cAdvisor does is, cAdvisor will collect all the metrics from pods and nodes. So since kubelet runs on per node, so if kubelet is running on worker 1, it will be collecting pod metrics for all the pods that are running in worker 1. Then there is a metric server. When you configure this metric server, like I have installed a metric server, and metric server is an add-on, it does not come with default Kubernetes installation. Having said that, there are certain managed implementations like Amazon EKS where you will see metric server is installed by default, and I think they have done that so that you can configure HPA right out of the box and you do not have to install metric server separately. Then what metric server will do is, metric server will scrape the kubelet. Understand that the kubelet is not sending it to the metric server. Rather, metric server is scraping the kubelet metrics endpoint to collect these metrics. So when you as a user run kubectl top, the client calls the aggregated API on the kube API server at this path. And then it is the API aggregation layer that forwards the request to the metric server, and you are served with whatever you requested. Here, if you are running kubectl top nodes, you get this output in your screen. So that is the architecture of metric server. Now let's discuss what is the next point. Next point is, metrics are in memory only, no history or dashboard. Understand this point. I made this at the very beginning itself, that it will just show you the current utilization, the utilization what is already there in the memory of metrics server. It is not storing these metrics somewhere for persistent storage. So these cannot be considered for long term, these metrics. Then the next point is, custom and external metrics extend HPA beyond CPU memory. Now if I go to day 20, what the point I'm making here is, do not limit your imagination to think that you can only scale your pods based on CPU and memory. It is not like that. You can also have custom metrics. Like we discussed in day 20, we said that there are something called internal metrics and then there are external metrics. What are internal metrics? Internal metrics are that are available in your cluster. For example, the metrics generated by your pods or your deployments, these are internal metrics. Then what are external metrics? External metrics are, maybe you want to scale your pods based on what is the queue length of Amazon SQS. Maybe you want to scale based on what you have configured in your Azure functions. So broaden your imagination. It is not just memory and CPU based on which you can scale your pods. Here I have also given another example where I have shown Prometheus server and adapter, because if you want to achieve this level of scaling, you may have to use some third-party tooling like I have here. Then these are exposed using custom metric API and external metric API. Custom metric API is for any custom metrics that you enable for your pods and deployments or any other native Kubernetes object, and then external metric API is for anything that is outside your Kubernetes cluster like Amazon SQS, Azure Functions, Amazon SNS, and there could be plenty more. This is just an example, and based on these metrics, HPA controller can scale your deployment or whatever object that you are using. I hope that is clear. Then let's move back to day 56. Another important point is API server has an endpoint called /metric. So if I go to day 35, in day 35 we discussed that there are different Kubernetes API endpoints, and /metrics is one of those endpoints. Now why this is important? Because understand that when you are using a monitoring tool will also tell you whether your API server is overloaded or not. What is the status of your kubelet? Is it optimally used? To use all these metrics, your third-party tooling like your Prometheus or any other monitoring tool that you are using like Datadog, New Relic, they can pull this metrics API and fetch the information about the API server and kubelet to check their utilization. So last point what I mentioned is API server and dashboard give advanced signals or UI, and here we can use /metrics. We can integrate this with our third-party tooling and also monitor our API server and kubelet. Now before I move to the next section, I'll go to GitHub notes because I want you to also read something else that I have pasted here that's just theoretical, so I'll let you read it. And this is beyond metrics server, so you can also see kube-state-metrics, Kubernetes dashboard, and I will let you read about these things. These are also other tools that are available at your disposal, but again, if you are working in a tightly governed environment, you would essentially be using an enterprise grade tool like Datadog, New Relic, or you will be using Prometheus, Grafana, which are configured to do end-to-end observability. Now let's move back to our diagrams, and then now I want to discuss Kubernetes logging. Now before I start this discussion, I will make one statement. When you are dealing with your Kubernetes cluster, there are two types of entities. First, there are things that are running as pods. Then there are things that are running as services. So if I talk about kubelet, container runtime, these typically run as services. And also if you are working with older clusters, you would also see kubeproxy is also running as service. And most of the control plane components along with your CNI and your kubeproxy, core DNS, all of these, they run as pods. So if I go to my terminal, if I run kubectl get pods -a, then you see there are so many pods running. So these are my workload pods, anything that is running in the default namespace, but anything that runs in the kube system namespace or Tigera operator namespace or Calico system, these all are there for the proper functioning of my cluster. For example, Calico and Tigera operator, these are used for my CNI. Then you have my control plane nodes, then you have kubeproxy, and you also have CSI node which belong to Calico. So the statement is there are few things that run as pods, and then there are few things that run as services. Now why this distinction is important? This is important because you can use native journalctl to check the logs of anything that is running as service. So if I clear my screen here and if I show to you systemctl status, I want to see the status of kubelet. Because kubelet is installed as a service, you can check the status using systemctl, and this says active and running. And similarly, I can check the status of my container D. And what is container D? Container D is the runtime that we are using. So if you see, this is also active and running. But Varun, how can I check the logs of this? You can do that using journalctl and -u. Here you specify the name of the service. So for example, container d. -u is there because this is also called a unit file. You see here the unit file, there is some warning as well. So container d, and then you can add a -f flag if you want to see live logs. Otherwise you can just press enter, and you see here are the logs of my container runtime. And if I quit this, I press Ctrl C, and then if I hit the up arrow, I can do the same thing for my kubelet. If I do this, I will see the logs of kubelet. But I want you to understand one thing very clearly. If this node dies today, then these logs are gone because they are being stored in the node itself. They are not stored in something external, something which has persistent storage. So if this node crashes, these logs are gone. And when you are working in a production implementation, you do not want to lose logs, because in certain governed industries like maybe healthcare or insurance sector, you will see that logs are stored for past 7 years. That is the compliance that certain industries demand. Hence, you must have some external means where you can store your logs. And compliance is another thing. But imagine if you have a control plane and that node crashed for XYZ reason, you would want to know why it crashed, right? You cannot just sit hanging for problem to occur again. You must see what the problem was, and you can only dissect, you can only perform post-mortem when you have logs in your external system. So understand that by default, all these logging mechanisms that I am showing to you, these are just limited to your nodes. If your node dies, then you have no permanent logging. So for that, you will have to configure something that we discussed in the beginning of this lecture. So this is how you check the logs of your services using journalctl. But Varun, what about my pods? And we have been using this command since the very beginning. So if I clear my screen, I run kubectl get pods. Here you see I have these pods. If I want to check the logs of any of these pods, I can just run kubectl logs, and here I can write demo pod. This will show me the logs for this demo pod. This demo pod is running Nginx, so these are the logs for Nginx. As simple as that. Now I also want you to understand one more thing. If I go into cd log, press enter, if I hit ls, then it is not just kubectl logs via which I can check the logs, although kubectl logs is the recommended approach. But if I cd into this, you see there are two directories which are of importance to us. One is containers and one is pods. So I will go to the pods because in the containers you will see just a symlink that points to these pods itself. So I'll go into cd pods. I will have to hold on. Let me write sudo here, cat here, and then what is the path? Let me do one thing. Sudo ls pods. Let's see what we have there. Now I want to see the logs for, now this, understand that this is showing the logs only for the pods that are being run in the control plane. But if I want to see the logs of Nginx, then I will have to go to the worker node where that Nginx pod is running, which is named demo pod. So if I go here I have opened my, hold on, let me also take console of my, I'll cd into downloads because here is where I have my private key. I'll zoom in here, I'll go to my browser, I will go to my console, I'll go to worker1, and then I will hit on connect. I will copy this command, I will paste it here, I'll press enter, and soon I will be taken inside this node. And see, if I had a good observability system, I didn't have to do that, right? I could have shown you the logs right outside in the console of my observability tool. So understand, it is very important to have a good observability structure. So I'll go into var log, and then what I'll do is I'll hit ls. I will first write sudo pods, it is pods, and then press enter. I should also write ls sudo ls pods, and then you see these are the pods that are running in this node, and you see Calico and kube proxy here because these are running as a daemon set. So as daemon set run on each node, that is why you see them here. They might not run in control plane node depending on the tolerations that your daemon set has. What I'll do is I'll write sudo cat pods, and if I do this, I can also cat the logs for my demo pod. So if I copy this, I paste it here. Oh, it's a directory. Hold on. I'll go here. I'll cd. Oh, I'll have to hold on. I know what I have to do. I'll have to add ls here again. ls and then nginx container, because I have 2 containers inside that pod, because I want to show you one more thing. That's why you see this here. I will copy this name nginx container. I will paste it here. Then I will go back here again. I will write cat here. I know someone is saying, why don't you sudo into it, Varun? Oh, this is also a directory. Let me write ls here again. Press enter. Yeah, it's 0.log. I'll write 0.log here. I will press Ctrl A, come to the front. Then I will add cat here. Finally, so these are the logs for my nginx container that is part of my demo pod. So you see, you can check the logs this way as well. There is another way I want to teach you. If you want to see the pods that are running in this worker, so you know that we are using containerd as our runtime. When we were using Docker, we could run docker ps and see what all the pods that are running. I should rather use the word container. What are the containers that are running in my worker node using docker ps? With containerd, you have trictl, which you can use to check what all are the pods that are running in your node. So here is the list for that as well. And from here as well, you can check the logs using crictl based commands. So now we have a good understanding of how to check logs using both journalctl and using the native location. And also we know how to check logs of pods and containers using the directories, but we also understand that kubectl logs is the way that is preferred. With this understanding, let's go back to our diagrams. Containers write logs to standard output and standard error. Now I want you to clearly know that the logs are written where they are written because the application developer has configured it that way. So I, as an application developer, must configure my logs to be written in standard output and standard error. If I do not do that, if I am writing the logs to a, let's say, a local file, then kubectl logs will not show me the logs. Understand that kubectl logs is just showing me what is there in the standard output and standard error, and this is done in between using the container runtime, which is allowing us to run kubectl logs and get the logs for those containers. It is under the hood, it is the container runtime that is working. But I want you to know, if your application developer would have not configured logs to standard output and standard error, then logs won't appear in kubectl logs. So if nothing is appearing in kubectl logs for your pod, then you have to ring the bell of your application team and ask them to configure proper logging. Second is runtime redirects these streams to node log files. Now runtime is your container runtime. So container runtime, as we understand, is running in each node. Container runtime is collecting all these logs from your containers, and then it is adding those to whatever directories you see here. So you see these all are the directories pertaining to, I'm talking about Kubernetes only. So pods, containers, all these are updated based on whatever container runtime is receiving from your containers, and container runtime will only receive these when your application developers would have configured standard output and standard error. Pod logs viewed with kubectl logs, we have seen this. Multi-container pods, kubectl logs pod name, then you can also type the container name. So for example, if I talk about, I'll first cd into my home directory. Then if I clear my screen and if I write kubectl logs demo pod, then this will just show me the logs for this demo pod. But this demo pod has two containers. If I come here and press tab, it will show me the next container, that is busybox. So if I press enter in this, it will show me the first container. But if I want to see the logs of busybox container, then I can write that name and press enter. It will show me the logs of busybox container. Now this I have done to show you something interesting. So I will cat into this file. It is 01, and this is the file that I used to create this pod. This is the manifest. Now understand what I am doing here. Name is fine, labels is fine, then the first container is nginx container, and this is normal. Then I am creating a busybox container, and here you see what I am doing, and this is the important piece. I am saying echo busybox log, I am saying add the date and type processing data, and this is the key here. Now I want you to concentrate on two things. There is angle bracket and 1, and then there is angle bracket and 2. So if I would have just had angle bracket 1 and angle bracket 2, they themselves just redirect output to a file named 1 and 2 respectively. But what we have done is we have added an and symbol here. Now adding and makes it a file descriptor redirection, especially to standard output and standard error. So if I type this will send it to standard output, and this will send the logs to standard error. Now your application teams would have configured something like this in your application, which is why when you are running kubectl logs along with the pod name, you are getting that output. If I would have not added this, then I would not have seen those logs. So right now, if I write the same command again, you are seeing these logs here because that is how I have configured my application. If I would not have written that, then I wouldn't have seen any logs. And let's see that in real time. So if I vim into 01, okay, I will go into insert mode, and what I will do is I'll quickly remove this, and then I'll come here, and then I will also remove this. Okay, I'll save this. I will now run kubectl apply -f and 01. This will it modify? Yes, I'm not allowed to modify that. So I'll run kubectl delete pods. I will delete the demo pod, and then I will apply that file again. Yeah, the pod is deleted. Now I will apply that file again. And if I now run that command where I can check the logs, if I press enter. But Varun, why are we seeing the logs? You just said that after removing that, I won't see the logs. I want you to clearly know one thing. So if I go to my Visual Studio Code, I will open that file there so that you can see in a better way. And here is my file. I'll zoom in here, and then I'll also add a hyphen so that these lines disappear for a while. Now you see, these are the two statements that were there, and I just removed these, and I said that if you don't have these, then you won't see the logs. But I also want you to understand that echo, the command by default, it writes to standard output and standard error, which is why you are seeing those logs there. But if your application is writing the logs to a file or to a, let's say, a custom location other than standard output and standard error, then you won't see those logs. So keep this important distinction in mind. Now let's go back to the diagrams, and here you see best practice. Apps should log to standard output, standard error, not custom files. Logs are ephemeral, lost when pod dies or restart. Ship centrally, as I said before. Maintain your logs in a central location which is persistent, and then you can have your policies for how much time you want to retain your logs. Retention size, now you see there were logs in the nodes, but I want you to know that those logs will not stay there forever. So if you want to see the logs for a pod for last 2 months, you might not be able to see that, because the retention there on your nodes depends on how you have configured your operating system. So retention size is based on the settings that your Linux admins would have done for the operating system. So these differ by project to project and distribution to distribution. It is better to check for how long or what is the maximum allowed size for the logs. So I have covered everything I wanted to cover. That's a wrap for this lecture. We explored observability, walked through metrics server architecture, and covered native monitoring and native logging in Kubernetes. Next up is control plane and data plane troubleshooting. If you have any questions, feel free to ask me in the comments section and I will reply. If this helped, do consider liking, sharing, and subscribing. Thank you very much.